Okay guys, we're going to start our do now with a little review of our vocabulary of our angle relationships. Remember, we've got two parallel lines cut by a transversal. That line going through is our transversal, resulting in 8 separate angles. So let's take a look. Angle 2 and angle 4 they're lying on opposite sides of a vertex, so they are vertical angles. Okay, and I'm also going to make a little note here, right? Vertical angles are equal. Angle 3 and angle 7, they're on the same side of the transversal. They're both those obtuse angles. One's on the interior, one's on the exterior. Those are corresponding angles. Those are also equal to each other. Angle 4 and angle 6, they're both interior on alternate sides of the transversal. One's on the upper part, one's on the lower. Those are our alternate interior angles. And those are also equal. Angle 2 and angle 8, both on the exterior, opposite sides of the transversal. One upper, one lower. Those are alternate exterior. Those are also equal. Angle 1 and angle 5, same side of the transversal, right? They're both those obtuse angles. Those are also going to be a corresponding angle pair. That's the type of angle relationship that in vertical angles we have the most of in parallel lines cut by a transversal. And speaking of which, angle 5 and angle 7 are also vertical angle pairs. Okay, don't forget we don't always have congruent angles. We can also have supplementary angles like angle 3 and angle 4, angle 3 and angle 6, angle 7 and angle 8, and so on. Here we are on page 7, parallel lines cut by a transversal, day 2. In this diagram, I'm reminded of our beach ball method. So our beach ball method, we create a circle around our vertex and we shade the opposite angles the same colors. And we do the same shading on our other vertex, our other set of angles. And our same color shading, so all our orange are going to be equal angles. Our opposite shadings, so in this case, our orange and our purple together are going to add to 180. Those are going to be supplementary. So same color shading congruent, different color shading supplementary, add to 180. And that's always just a nice little help as we go to work with our angles. So here we're taking our parallel lines cut by a transversal. We want to identify the relationship between the angles and use that to our advantage to set up an equation and solve. So if I look here, we've got parallel lines cut by a transversal. What I see is I have angles on opposite sides of a vertex, which tells me they are vertical angles. And they are equal. So we're going to set them equal to each other. If I wasn't sure, I could do my beach ball method. Shade one angle. Shade its opposite. Those angles have the same shading, so they are equal. So equal means 2x plus 8 is equal to 4 times 2x minus 2.5. First step, we're going to distribute that 4 to both terms. 4 times 2x is 8x. 4 times 2.5, well, 2 times 2.5 would be 5. So 4 times 2.5 would be 10. So 4 times negative 2.5, negative 10. Now we've got variables on both sides. I'm going to subtract 2x from both sides. We get 8 equals 6x minus 10. Add 10 to both sides to get our constants to the other. 18 equals 6x, divide both sides by 6, and we get 3 is equal to x. So x is equal to 3. And that's all we were asked to do was to solve for x. Right? All right. So our next diagram, a little bit more challenging. I've got the parallel lines cut by the transversal, and this is just an extra line. We can just ignore that, pretend like it's not even there. We've got our angle right here, 3x plus 32 and 5x minus 60. As I look at these two angles, they don't fit to our vocabulary words. They're not alternate exterior. They're not both on the exterior. They're not alternate interior. They're not both on the interior. They're not on the same side of the transversal, so they're not corresponding. They're not on opposite sides of a vertex, so they're not vertical. So it kind of leaves us wondering. What I want to notice is if I take 3x plus 32 and I bring it down to its corresponding angle, that's going to be right here. And from there, I can see that those angles are supplementary. Okay, so I'm just using the fact of a corresponding angle. So I'm just using that to my advantage, sort of replacing it. You may have also seen, ooh, I can put it here. It's its alternate exterior angle. And again, we would see they were supplementary. So that's up to you there. We also could have used our beach ball method, going through and doing our angles there, and do it here also. If I notice my 3x plus 32 is white, my 5x minus 60 is orange, opposite color shadings tell us supplementary, add to 180. So that's another strategy. So they're supplementary, they add to 180. We're going to make our equation 3x plus 32 plus 5x minus 60 equals 180. 3x plus 5x is 8x. 32 minus 60 is going to be negative 28. Okay. Let's add 28 to both sides. 8x is equal to 208. Divide both sides by x, and that's going to give us, let's see, 26. X equals 26. Okay, and that's really what we're going for here today in our classwork, which is page 8 and 9. So you're going to go through, set up an equation, solve for x, and state the angle relationship. Okay, so here I can see they're corresponding. I would write corresponding. I know corresponding angles are equal. So we're going to set them equal to each other, and I would solve. Again, we want to review that vocabulary. Feel free to use your notes from yesterday to help you with the vocabulary. And we're submitting our work on Google Classroom, either through the PDF with Cami or the Google Doc with images. Okay? Have a great day. And a little math joke for mathy folks for us. Today's is, how are mathematicians like the Air Force? Well, they both use pilots. Get it? Pilots? Haha.